In this lesson, we'll learn that building strong memories takes work and wisdom. Now, in previous lessons, we've seen this diagram about the learning journey. So we're processing a lesson, the information is in working memory, and what is in working memory has the potential to be stored in the long-term memory system as memory traces. So the neurons activated by the learning, some of them are going to grow stronger synapses with each other, and that's going to represent the information we're attempting to learn. And then the test comes along. We process the test question in our working memory system. We use that to search our long-term memory. We're hoping we can reactivate those very same memory traces that were formed during the initial learning process, and then we can retrieve that information, load it up into the working memory system, and answer the test question. In the remainder of the lesson, I'm going to introduce two concepts, and then we're going to see how these concepts help us map out what's happening over the course of our study journey. Now, the first concept is retrieval strength. And this gets at this question: how easy is it to retrieve the desired information? And by easy, we could also mean how quickly can we access the desired information. Now, we might be retrieving information from two possible sources, the working memory system or the long-term memory system. And so this arrow here would indicate that the information, I was just processing that information, so it's still stored in the short-term memory system, so I can quickly retrieve that information from my short-term memory system. But I might also be using my working memory to search the long-term system, where I find the information reactivated and load it up into the working memory system. Now, that might be easy as well if I have strongly stored the information in my long-term system. So retrieval strength is sort of our own experience of the retrieving of a memory. Did it come easily? Was it quick? Or did I struggle and maybe fail? That's retrieval strength. The second concept we're going to call storage strength, and this is a measure of how strong is the memory trace in the long-term memory system. So we might have weakly stored memories because the synapses were not really very strong between the neurons, or we might have strongly stored memory traces because a lot of synapse growth occurred between those neurons in the memory trace. All right, now we're going to use two graphs to follow these two concepts: retrieval strength up top, storage strength on the bottom. And notice on both graphs, the x-axis shows that we're going to have 3 study sessions separated by sleep. Now you'll notice then the y-axis up top here indicates the ease or speed of retrieval, so that's retrieval strength. So sometimes when the line is high up here, it means we have high retrieval strength. At other times we might have low retrieval strength. And likewise down here, for storage strength, if the line is low on the y-axis, then that's low storage strength, whereas over here, apparently we have high storage strength. All right, now let's begin the process. Here we are in our first study session. So maybe we're reading a textbook, or we're watching a video lesson, or maybe we're in class processing the lesson. Well, during that time, we're going to enjoy high retrieval strength for the information that we're processing. And the reason is that information is currently in the working memory system, the short-term memory system, which one of its features is that we have fast, easy access to the information that is in our working memory system. But notice on the bottom graph, it indicates that the information that we're studying or processing has not been strongly stored yet in the long-term memory system. So we have low storage strength. Now, this situation presents the learner with a possible misconception that they might fall prey to, that we think we know the information because we can easily retrieve the information during the study session. But the reality is, easy retrieval is due to short-term memory, not high storage strength in long-term memory. So if we go back to the previous diagram, when we're studying and we're understanding the material, and we could even sort of recite the information to somebody else, we have the illusion that we have already made strong memory traces in our long-term memory system. But that's not the case. That process will take time. Right now, During the study session, we're simply enjoying high retrieval strength because the information is in the working memory system, the short-term memory system, which gives us high retrieval strength. Now, here's a key relationship that psychologists argue for, that storage strength determines the rate of forgetting. So because we have low storage strength during this first study session, it means we're going to have fast forgetting. So when we finish our study session and then, for example, go to sleep, it often happens that the next morning we cannot remember what we were studying the night before. And this is a feature that we need to understand about our memory systems. The short-term memory system and the long-term memory system are different, and we don't want to confuse the two. It's as if students forget that they will forget. Now, how much will we forget? Well, this is where we want to test ourselves to find out. So we must test ourselves later on. And here we're going to use a form of testing called retrieval practice, where we're simply going to try to call information to mind. And we want to make sure we're doing that. We're trying to get the information from the long-term memory system. Now, how do we ensure that? We must have a delay between the study session and the time that we are testing ourselves. And the purpose of the delay is so that the information is no longer in the working memory system. So, for example, the next morning, when we try to remember what we were studying the night before, we are trying to access the information directly from long-term memory. So when we do retrieval practice after a delay, like after sleep, that will give us a good measure of storage strength. How well did we store the information in our long-term memory system? This gives us important information as learners. Psychologists call this metacognition, which is being aware of your own level of understanding or knowledge. In this case, being aware of how well stored is the information in your long-term memory system. Retrieval practice gives us excellent metacognitive information. And while we're at it, and during our first study session, let's consider misconception number 2. We think that long study sessions are good. Unfortunately, psychologists argue that prolonged study sessions become less effective with time. So let's say we were studying for half an hour and we get the bright idea, you know what, I'm just going to spend 2 more hours studying the same stuff. The problem is, psychologists argue that we're not going to be making gains in the storage strength like we would want to. So the reality is that we will be making little gain in storage strength if we just keep on studying for hours and hours. And one proposal for why this is that hippocampal synapses have already reached a plasticity limit. So let's say by a half hour, 45 minutes, your hippocampal neurons have already been stimulated and they're already growing stronger synapses to some maximum limit. Further study cannot lead to increased synapse strength. So those hippocampal neurons that were already activated by the study session can't underwrite any new learning. So those hippocampal neurons that have already been activated by the study session, it's like they're kind of saying, hey, we already learned the information. We can't grow our synapses any stronger than we already have. So further study becomes less valuable because you've already exhausted those hippocampal neurons that were activated by studying that particular set of information. The recommendation here is to use short study sessions with breaks. Now, again, this is sort of cutting-edge research, but here's one of the ideas. During the first study session, there will be a set of hippocampal neurons that will grow stronger synapses to represent the learning during the first study session. But if we take a break, then when we return for the second study session, it'll be a different set of hippocampal neurons that will get used to make memory traces for the same information. You see, if we don't take a break and we just plow ahead for 2 hours, 3 hours, we're trying to activate those same hippocampal neurons that have already strengthened their synapses. But if we take a break, we can recruit new and fresh hippocampal neurons to make new memory traces for the same information we're studying. And that will benefit us later on when we go to sleep and do memory consolidation. All right, so now let's kind of step back and take a look at what seems to be going on over the course of 3 study sessions separated by sleep. Notice on the bottom here, what we have is we're building stronger memory traces in the cortex. So we're increasing storage strength. And look at what effect that has on retrieval strength. So up here, we have the lowest level of retrieval strength here after study session 1, but notice after study session 2, we have higher retrieval strength. After study session 3, we have even higher retrieval strength. And notice these are, we're indicating positions here that are in between study sessions. Of course, we're going to have high retrieval strength during our study sessions because we're loading the information into working memory. But we want to have high retrieval strength in between study sessions, right? That's what it is to know stuff. You can tell people things you know at any time during the day, not just right after you were studying that information. So to be well educated is to have high retrieval strength for all the kinds of stuff we're trying to learn. And why do we have that high retrieval strength? Because we built high storage strength. We built strong memories in our cerebral cortex. So notice then, when we have high storage strength, strong memory traces in our long-term memory system, look at the slope of the forgetting. It's a more gradual slope. So we're going to have slower forgetting because we have strong memory traces. Contrast that slope of the line with the very steep forgetting right after the first study session. So notice then there are 2 ways to have high retrieval strength. As we saw during the first study session, but it applies to other study sessions, whenever we're studying material, we're loading the information into the short-term memory system, the working memory system, and that's why we have high retrieval strength, regardless of what's happening in our long-term memory. But if we have built strong memories in our cerebral cortex, so we have high storage strength, then we can enjoy high retrieval strength at any time, not just when we're studying, but between study sessions. And that's what it is to be well educated, that we have quick, easy access to all the information we're trying to master. So the goal then of our approach to our studies to become educated is to build strong memories in the cerebral cortex, and that will allow us easy and fast access to everything that we're learning. In part 2 then, we'll take a look at what are the best practices to build these strong memory traces in our cerebral cortex.